So welcome you all for this session on basic concepts of refrigeration. So we will cover the basic concepts of refrigeration in this session. So the term refrigeration may be defined as a process of removing heat from a substance under controlled conditions. So what is refrigeration means? The term refrigeration may be defined as a process of removing heat from a substance under controlled conditions. So it also includes the process of reducing heat and maintaining the temperature of a body below the general temperature of its surroundings. So in other words, the refrigeration means it is a continuous extraction of heat from a body whose temperature is already below the temperature of its surroundings. So the textbook definition for refrigeration will be: a refrigerator is a device which is operating in a cycle, thermodynamic cycle. Cycle means thermodynamic cycle, maintains a body temperature lower than the temperature of the surroundings. This in similar to that of refrigerator, we are having heat pump. So heat pump is a device which is operating in a thermodynamic cycle, maintains the body temperature higher than that of the surroundings. So the requirements of refrigerator will be there in hot countries, and the requirement of heat pump will be there for cold countries. So next one is we are having one more process, that is air conditioning. So air conditioning is a process used to create and maintain certain temperatures relative to humidity and air purity conditions in indoor space in addition to refrigeration process. So in addition to the refrigeration process, we are controlling the certain parameters of the air like temperature, relative humidity and purity of the air in case of refrigeration. So this process is typically applied to maintain a level of personal comfort in case of refrigeration systems, so that the people will be working efficiently with the air conditioning systems. That means in refrigeration, we are only cooling the temperature below the atmospheric conditions or surroundings. Whereas in case of refrigeration, air conditioning. So in case of air conditioning, we are cooling in addition to the cooling, that is below the atmospheric conditions, we are controlling the other parameters of the air like temperature, relative humidity, purity of air. All these things will be there in case of air conditioning systems. So this is the diagram which will be representing: one is refrigerator, the one is hot heat pump. So the cold refrigerated space will be there. So we are continuously extracting heat from the cold refrigerated space, so that the cold refrigerated space will be maintained at a temperature lower than that of the surroundings. That is called as refrigerator. Here heat pump will be there. No, that will our focus will be on warm house, where we are continuously extracting heat. So we are continuously, this is the warm house where our focus will be there. We are continuously sending the heat with help of heat pump, for which we will take the external work. So this is called as heat pump. That the major difference between a refrigerator and heat pump will be. So in case of we are continuously extracting heat from the low temperatures and we are sending to the atmospheric conditions. And in case of heat pump, we are taking the heat from the atmosphere and continuously sending to the warm house. So that is the difference between refrigerator and heat pump. Coming to the refrigeration effect, the rate of heat absorbed from a body to be cold is called as refrigeration effect. So it is nothing but unit of refrigeration capacity will be, it is amount of heat energy removed per unit time from a space to be cooled by the refrigeration process. It is expressed in kilowatts or kilojoules per second. It is also called as capacity of the refrigerator. Generally, the units for refrigeration effect will be ton of refrigeration. So the ton of refrigeration may be defined as, it is the rate at which heat is removed from 1 ton of water at zero to produce ice at zero in 24 hours. So the rate of heat absorbed by the system from a body to be cooled, equivalent to the latent heat of fusion on 1 ton of ice from under 0 degrees centigrade in 24 hours is called as 1 ton of refrigeration. So 1 ton of refrigeration is the ratio of rate of heat absorbed by the system from a body to be cold, equivalent to the latent heat of fusion of 1 ton of ice from under 0 degrees centigrade in 24 hours. So the value will be equivalent to 3.5 kilowatts. So 1 ton means 1000 and Cladson's heat will be 335 in 24 hours. No, so 1000 into 334 divided by 24 into 60, the value will be coming around 230 kilojoules per minute. But in actual practice, the value is taken as 210 kilojoules per minute. So, but 210 by 60 means you will get around 3.5 kilowatts. So, 1 ton of refrigeration means it is 3.5 kilowatts only. Next one is coefficient of performance is a unit we are using for this heat pump and refrigerator. Though it is a measure of effectiveness of the refrigeration system, it is the ratio of refrigeration effect to the input work required to produce the effect. So COP is nothing but refrigeration effect divided by work we put in order to get that refrigeration effect. So COP will be generally the greater than unity. So there is a relative COP concept is also there. It's the ratio of actual COP to the theoretical COP. So generally, why we are using COP, whereas in case of heat engines we are using efficiency means COP indicates the effectiveness of a refrigerator or heat pump. For a refrigerator, the desired result is extraction of heat from a space. Generally, the value of COP of refrigerator is generally it will be more than unity, but the value of efficiency will be less than unity. That is the reason why we are using different terminology for refrigerator and heat pump and separately for heat engine. That is efficiency. COP for heat engine and refrigerator and efficiency for heat engines. So this is the diagram which will be representing the refrigerator block diagram. So here body at A will be there. We are continuously extracting heat from the body so that it will be maintained at a temperature lower than the surrounding temperatures. This is the body which is maintained at lower temperature lower than the surroundings. So which is the refrigerator will be working on thermodynamic cycle, so which is called as vapor compression refrigeration cycle. The main components will be evaporator, compressor, and condenser and expander will be there. So and we are extracting heat and we are rejecting to the heat to the atmosphere for which we are consuming certain amount of work. So that is called as a refrigerator. Here now the COP will be called as a desired effect by work input. Desired effect will be Q2 here and work input will be W. So desired effect Q2 by according to first law of thermodynamics, we can write net heat is equal to net work done. So from that you can write net work is equal to Q1 minus Q2. Therefore COP of refrigerator will be Q2 by Q1 minus Q2, or COP K naught will be T2 by T1 minus T2 we can write. Next one is heat pump is there. In heat pump now our focus will be at uh, here body 2. From atmosphere we're continuously taking heat with help of thermodynamic cycle and we are rejecting heat to the heat pump and then the space now which is to be heated. So our refrigeration, our heating effect will be Q1 and work supplied will be W. So the according to first law of thermodynamics, work is equal to net heat, that is Q1 minus Q2. Therefore we can get Q1 by Q1 minus Q2. So if COP of H heat pump and minus COP of refrigerator, no, if you subtract means Q1 by Q1 minus Q2 minus Q2 by Q1 minus Q2. So you will get Q1 minus Q2 by Q1 minus Q2. Therefore you will get 1. COP of heat pump minus COP refrigerator will be equal to 1. That's why you will get COP of heat pump is equal to COP of refrigeration plus 1. That means the COP of heat pump will be always greater than COP refrigerator by 1. So where we are using this refrigeration means there are different applications will be there. Domestic air conditions, domestic refrigerators, automotive air conditionings, evaporative coolers, water coolers, commercial refrigeration like dairy, cold storage and ice plants, many processing industries, chemical industries, commercial air conditioning systems like multiplex hospitals and other buildings. Now people will be using this kind of refrigeration and air conditioning systems. So this is the basic introduction about the refrigeration and air conditioning system. So in the coming classes, we'll discuss about the various kinds of refrigeration and air conditioning systems. Thank you and all.